Hey, AP Stats, Mr. Ellinger here, and we're going to give you some of the answers to the homework that you did over the weekend, so that you can go over it and you can know what your questions are. And make sure you let me know what your questions are and the things you want me to do on Friday to add to this, because I won't be in class today, and so I need to hear from you what things are the most challenging. So please send me that information. All right, so let's do this problem. This was number 45 from the homework, and I just want to go through a full hypothesis test showing you all the bells and whistles. Remember that you'll get this outline, not maybe quite all of this, but you'll get an outline when you have a test on this for this chapter. It's just that I'm giving you some time to kind of learn the outline, and then once you get to next chapter, then next unit you're going to have to actually remember this outline and do it yourself. Okay, let's do it. So the principal surveys students about parking. P stands for the true proportion of students who approve of parking, and the null hypothesis is that the true proportion is 0.37, because that's what was happening beforehand. So we assumed that before that the change that they do doesn't have any influence, it doesn't change anything, and everything stays the same. So the null is nothing changes. The alternative is that this principal wanted to improve student satisfaction, so he wants the proportion to be greater than 0.37. Now, there's some evidence that this is true, because out of the 200 students, 83 out of 200, the p-hat is 83 out of 200, which is 0.415. So it's higher than 37%, but is it high enough? That's what we have to find out. All right. Next up, assumptions and conditions. Is it a random sample? He says so. Sample, check. 10% rule. 200, the amount he sampled, is less than 10% of all students, because 10% of 2,500. Right? Because 10% of 2,500 is 250, 200 smaller. Check. And finally, the NP, N1 minus P. So 200 times 0.37. Now, this is the big difference, is that we're using the null value here. We're not using the data. And 200 times 0.63. I've probably said that a bunch. I'll just check the small one. 200 times 0.37. What's that? 74. Oh, yeah. We're definitely greater than 10. Greater than 10. So therefore, we're going to do a one proportion z-test. Standard deviation, worked it out ahead of time. So the model is that we assume 37% is right. That's the null. We assume the null is true. And then the standard deviation, I worked it out ahead of time, is 0.034. So one standard deviation away is 0.404. And 0.145 is bigger than that, but not a lot bigger than that. I don't know if this is going to be extreme enough. The z-score is what did I get for a proportion minus what's the null proportion, that's the center of the distribution, divided by the standard deviation. Haven't done that. 0.415 minus 0.37, got it, divided by 0.034. 1.32, which is 1.32. That's how we performed on this test. We got a z-score of 1.32. It's pretty high, but it's not that high. What's the p-value? I'm going to work that out right now. Let me pause it. Okay, I've done the rest of the work. The p-value was about 0.09. I did the norm CDF. Now, I just listed things off here. You don't have to show work in terms of your normal model on these. If you just said p-value is 0.09, that's totally fine. There's so many parts to these problems, you don't have to show the normal setup, like what you plugged into the normal model. The decision is we failed to reject because 0.09 is greater than 0.05. And here's the conclusion. I put that part down here instead. It doesn't matter. As long as you create that linkage, why did you fail to reject the null? And I said with a p-value of 0.09, which is bigger than 0.05, we failed to reject the null. We don't have convincing enough evidence that student opinion has improved. So it's gone up, but the chance of getting results like this or even more extreme, it's 9% chance, which is like, okay, it's kind of unusual, like it's not likely to happen, but it could just be random chance. And if we're going to go with that level of significance, that significance level of 0.05, if that's going to be our cutoff, then we really need the p-value to be lower. We need this to be a more unusual thing for us to conclude that it was actually the result of, or actually that student opinion is really higher and that it's not just random chance instead. So the ultimate result here is that there's no conclusion. There's insufficient evidence to conclude it. All right? That's the number 45 first part. I'll put the rest of the answers just written down.